Okay, so in today's video, we're going to look at graphing tangent. So once again, we are back at the unit circle. We're going to be using that to help us find our points in order to graph tangent. So normally when we are graphing sine and cosine, we are using our quadrant angles. So we can start there again. We can use those four and see what we discover. Now, the one thing we got to make sure that we remember is tangent is sine over cosine. Now, if you do not remember where that comes from, let's go back to a triangle. So I just drew a quick triangle right here that we can pretend is in the unit circle somewhere. But if this is our angle theta that we are using, right, we know that this is x on the x-axis, this is y, and this is our r, or our hypotenuse. Now, if I were to label it using our trig sides. So I'm thinking opposite, adjacent, hypotenuse. This is going to be opposite, adjacent, and hypotenuse. Now, if we're thinking SOHCAHTOA, we know that tangent is TOA, OA, opposite over adjacent. So that means tan is y over x, or sine over cosine. So when we try to find these points, we're going to be doing sine over cosine. Okay. So if we start with tangent of 0, that's going to be sine of 0 over cosine of 0, which, knowing our points are cosine comma sine, I know that's going to be 0 over 1, which is just going to be 0. Okay, and then if I do tangent of pi over 2, same thing, that's going to be sine of pi over 2 over cosine of pi over 2, which is 1 over 0. And we cannot divide by 0, right? That's going to give you an error in your calculator. There's no feasible way to have one part of nothing, right? So this is going to be undefined. And if you remember from when we graphed rationals, when you are undefined, that is going to be a vertical asymptote. So this is definitely going to look very different from sine and cosine because there's going to be a vertical asymptote here. So I'm going to keep going. I'm going to look at tangent of pi. And then tangent of 3 pi over 2. I get that that's going to be undefined. And then when I go back to tangent of 2 pi, that'll be the same as tangent of 0, which will bring me back to 0. So already I can see, a pattern going on, right? We have 0, undefined, 0, undefined, 0, and as we keep going, it'll repeat undefined, 0, undefined. So I know there's going to be a lot of asymptotes, but I need a little bit more in between, right? I can't have a graph with two asymptotes and then one point in the middle, right? Wouldn't really make sense. But as I'm looking at all these points in the middle, some of them I'm going to get root 3 or root 3 over 3, which isn't really pretty. I don't really want to graph those. I'm capable of it, but I like using nicer numbers. So that's where I'm going to pull tangent of pi over 4. Because if I look at tangent of pi over 4, that's going to be root 2 over 2 divided by root 2 over 2, which is just going to give me 1, right? And the point 1, that's nice, right? That's a nice number. I'm comfortable using that as a y value. So I'm going to use those as well. I'm going to use 3 pi over 4, 5 pi over 4, and 7 pi over 4, because all of those have those root 2 over 2 dividing each other, but some obviously will be negative, some won't. So I'm going to fill those in here. So I filled those in between all my angles. So pi over 2, 3 pi over 4, plugged in 5 pi over 4, and 7 pi over 4. And as you start to look at this pattern, right, so 0, 1, undefined, -1, 0, 1, undefined, -1, I think you're starting to see that that same pattern is repeating. So from 0 to pi to 2 pi, 2, 2, you see the pattern twice. And that is on purpose. And that is because the period of tangent is actually only pi. So normally for sine and cosine, right, our period was 2 pi. It took 2 pi to get around our unit circle. But for tangent, it only takes pi, right? After we get past pi, we just start repeating the same pattern. So now when we're finding our period, we're only going to be using pi, not 2 pi. And one thing that we can note here, right, is whenever sine is equal to 0, tangent will equal 0. And whenever cosine equals 0, tangent's going to be undefined, right? And we know this because if sine is on top, so whenever sine is 0, obviously tangent will be 0. And whenever cosine is 0, that means the denominator for tangent is 0, so it'll always be undefined. So that, again, that pattern's sort of repeating. So this right here, if we take our pattern, we put it onto a graph, this is what one period of tangent looks like. So between two asymptotes will always be our period. So we can see we have an asymptote, we have that -1, 0, 1, and then that asymptote. And we can see these are clearly at pi over 4 and negative pi over 4. Now, we didn't use negative pi over 4 and negative pi over 2, right? Which we can find on our unit circle. Negative angles just go in the opposite direction, so we can find those pretty easily. But we graphed from 0 moving towards 2 pi. So if I were to take this pattern, right, and I were to go next with 3 pi over 4, then pi, it'll look something like this. So again, that period of tangent, right, also oscillates, so it's going to continue. So you're going to have that same, it is also periodic, so that pattern repeats over and over. Now, if we were to only graph between 0 and pi, it would just be looking at this section right here, which is considered one period, but it kind of looks like it's half of one period and half of the other, right? Because it starts in the middle and ends sort of in the middle, whereas starting and ending with two asymptotes seems and feels a little bit cleaner. Either one works. Both of those are considered one period. There is not a right or wrong way, it's really up to preference. So whichever way you prefer to graph it, both will get you the same graph. And I will likely ask you to draw two periods anyways, so it doesn't really matter which one you choose. So let's look at these transformations. So what's super nice about tangent is all of those transformations affect tangent pretty much the same way. So A is again going to be in front of tangent, that's your amplitude, it is always positive, and it's going to determine how steep that graph is in the middle. For a period, still pi over b, so it's still our it's no longer 2 pi over b because the period of tangent is just pi. So we're going to be doing pi over b. Phase shift, still c over b, or you can set what's in parentheses equal to 0, either one. And D, still determine your vertical shift, whether or not it goes up and down. So if we look at this first problem, I see that I have an amplitude of 5, I have a vertical shift up 3, and I have a B value of 1/4. So in order to find my period, I'm going to do pi over 1/4. and I get a period of 4 pi. And again, what's nice about this is to find our critical angles, we are once again dividing our period by 4. Now, we know our critical angles will go up by pi. Now, this is once again where it's sort of up to you how you want to graph this. You can either start at 0 and go over pi, or you can sort of do that one period from asymptote to asymptote and going into the negatives. So I'm going to show the critical angles for both. You just want to be careful depending on which one you choose. Obviously, we'll have a different pattern. So you have to make sure that depending on which one you use, you know what pattern you're using. And if for some reason you forget or you want to double check, again, go back, plug these into your equation, plug in your angles, and use that unit circle knowledge to make sure you're looking at the right point. So let me show you what that'll look like. So either our critical angles will have 0 in the middle, we'll have 2 critical in the negatives, I guess on the graph to the left, and then 2 to the right or on the positive side, or we can start at 0 and just add critical angles all the way up the same way we did with sine and cosine. It'll just have a different pattern. So that would look like this. And again, notice, right, at 0, we are at 0 for both of these. At pi, we are at 1 for both. We're just looking at different critical angles. So from there, we're going to multiply by our amplitude. And if you are undefined, right, if we have a vertical asymptote, no matter what our amplitude or vertical shift is, it is still an asymptote. That does not change. Undefined times 5 is still going to be undefined, right? That's not going to change. So I'm going to multiply those other values by my amplitude. So I multiplied everything times 5, and then I'm going to add 3 because I have a vertical shift up 3. Again, undefined stays undefined. That does not change, but I'm going to add 3 to all of my other values. And those will be my final y values. So the last thing to do is pop them on my graph. Which I will do right now. If you want to try to graph on your own, you may do so. I will do that now, and it'll pop up momentarily. So I did spread mine out a little bit. I went over by pi over 2 to sort of spread it out a little bit. You also could have gone over by pi, totally up to you. But we can see our vertical asymptotes at 2 pi and negative 2 pi. Obviously, our next vertical asymptotes are off the graph a little bit. But then we have our middle 3 critical points, as you can see. So this is about 3 periods on the graph, so a little more than 2. Last thing, we can look at domain and range. So if domain is our x values, this is going to be the tricky one because we need to include those vertical asymptotes. So if I were to just write the domain of my middle period, right, it would be negative 2 pi to 2 pi with soft brackets. Because we have vertical asymptotes there, we want to use the parenthesis brackets. And then for range, we do not have any restrictions. We can see those arrows, so it's just going to be negative infinity to infinity. So for domain, we could obviously put more than one period. Right? If we were to do this second period after, we would do another u, 2 pi to 6 pi, and then you could keep going on infinitely because the graph will continue to go on infinitely. But again, we just want to make sure for domain, we're focusing on those asymptotes and making sure we're excluding those in our domain. If you have any questions, let me know. Hopefully this was helpful. Thank you for watching.